So thanks all for standing by and welcome to today's webinar, where we'll be covering Terraform Enterprise cost estimation for cost control, as well as clustering for availability. On the webinar today, we have two of our Terraform product managers, Glenn Gillen and Jordan Glassner, where they'll be walking through more details around the features and conducting demos. During the webinar, please feel free to type in your questions into the Q&A box. And we'll get to the questions at the end of our webinar. This webinar will be recorded and the recording will be sent out to all folks who've registered within a couple of business days. And with that, I'm going to pass it over to Glenn to kick us off.
Thank you very much, Caroline. Hi, everyone. I'm Glenn. So let me get straight into the presentation and we'll share my screen. So today we're going to talk about Terraform clustering and cost estimation, as Caroline said. Let me get started. We've got on the call today Jordan, who's a product manager focusing on Terraform Enterprise, and we're talking to the clustering side of this. And I'm Glenn. I'm product manager looking after governance, of which cost estimation falls under. So the agenda for today is we're going to talk about cost estimation. I'm going to drop into a demo. We'll talk about clustering and what that is and how it works. Jordan will go through that as well, and then at the end we'll have some time for some Q&A, so you can drop your questions into the chat as we go along. So what is cost estimation? Well, let's start at exactly what the problem was. So anyone who's delivering services on a cloud or deploying resources into the cloud providers has a bit of a challenge. It can be really difficult to understand the spend that's happening, especially at the earlier stages. And what a lot of the existing tooling or processes that customers have in place is very after the fact. So you'll get the billing management report or some kind of report from the vendor, usually at the end of the month, and you'll then go back and try and work out where exactly those costs have been apportioned. And that presents a whole range of problems for teams at every stage of the organization and the life cycle. So the solution we wanted to implement was let's give teams better visibility into exactly what infrastructure is going to cost as early as possible in the process. Let's do it at a per workspace level, so it maps back to how they're thinking about their infrastructure and their resources. And let's give them some tooling around being able to take action on that. And so the integration with policy as code, excuse me, and Sentinel means that they can start enforcing best practice and policy decisions actually in code automatically. And from there, you can start taking action to try and analyze and optimize exactly how you're apportioning spend and what you can do to reduce it. I've got an example here from a customer we can't name, but I have worked at a company that had a very similar situation like this previously, where you spin up a bunch of nodes for a POC or some kind of project and it doesn't sort of last much longer. And you discover months later that this stuff's still running and it can be very expensive. In this case, it was $72,000 worth of unnecessary spend that was being done. And that's not necessarily anyone's particular fault. It's just that it's really easy to spin these costly resources up at the time and not have a full appreciation for exactly how much cost you're provisioning at the time. And I'll give some examples of that in the demo and how easy it is to do. And so cost management, the workflow here is you embrace Terraform, you use infrastructure as code to manage change. You push that change into Terraform. We generate a plan. And as soon as we've got the plan and we know what resources we're going to provision, we'll then query the vendor's APIs to get a cost estimate for those resources that we can do that for. If you're using Sentinel, you can then feed that into a policy check and enforce some rules around the change in cost or the total aggregate cost. And if everything is fine, we run the apply and those resources are provisioned in the cloud for you. And so to just recap, there's a few things, like if I take away anything on what cost estimation is, I want to reinforce that this is like preemptive visibility. As I said, most other tooling is very much after the fact. This brings it forward so you can see before you've actually applied the change, what those resources are estimated to cost. It has policy as code integration, which means that you can come up with some company-wide policies and put them across all of your workspaces and have them applied automatically. And with that automated compliance comes the ability for escalation workflows. So you can have an approval process for changes over a certain threshold, or you could just have mandatory strict enforcement to say something like a development environment is never allowed to cost us more than a few $1,000s. And so I'm going to run through those scenarios for you now. I'm going to switch over to doing a demo. So, and it's going to be a live demo, so let's all cross our fingers and hope that the demo gods are with us today. hide those controls. So here we have on the left, Terraform Cloud. I'm logged in. This is a workspace I've got to demo cost estimation. And on the right-hand side is some Terraform config that will deploy some resources to AWS. And we have an auto-scaling group here with a maximum size of just a single node here. And what we're going to do for this change this to be 3. And we'll save that. We'll save that. There we go. And we will commit that to Git. So we'll make it's a highly available setup now. And we'll push. Okay, and that's going to push that up to GitHub. And we'll see on the left-hand side here in just a second, the hook will fire that will detect this change. We'll go through the plan phase. Excuse me. We'll estimate what those resources are worth. And we'll come back with a number. Something I'll point out here is with the auto-scaling group, there's a lot of things that can happen behind the scenes sort of during a runtime that will affect the number of instances that are running at a time. If you're scaling automatically, this value could go up or down. And so what we actually do is we estimate based on the max size. So what is the maximum size we expect under load this auto-scaling group might cost us? And we take a very conservative view, like a slightly pessimistic view even, on what that cost will be, just to make sure that you're handling kind of worst case scenario and estimating reasonably. So we'll see here the plan applied. And this change is going to cost us $400 because we're running some really large instances. And if we expand this down here, we'll get a breakdown on exactly what that was. And we'll see that we're adding a few more nodes. And we can either say that's all fine, confirm and apply, or we can discard that run. So for the sake of the demo, I'm just going to discard this run. We don't need to proceed with this. But what you see here is, like I said, now developers who have gone through this process have a sense for what this is going to cost. It's really easy to sort of change, one number here or a instance size there, and have these knock-on effects. To give you a sense of that, let's change this to T3 micros, for example. Save that. We'll push. What's not working? Why is that not working? I'll back to that later. What we'll see here as well, we had some policies that run but didn't actually pass. Sorry, that did pass, but nothing was failed or raised for escalation there. And so what we want to do now is show you the example of what happens if we decide that we don't want this, we want to enforce some policy around this. Let's say that we are going to require every resource to sort of make incremental changes. We don't want big, expensive changes going out without some oversight. So the way we can do that is to, let's make a bigger change here. I have to just drop out to my terminal for a sec to change this. Go back to the runs. Similar story will happen here. See, a bigger change has been, the hook has been fired already. This is running. And what's going to happen here is it's going to run now a sentinel policy that is checking that the change is within a certain approved, pre-approved increase. And what that's going to do is take the delta in monthly cost. So how much is this change expected to influence the cost of this workspace for a month? We're going to make sure that it's less than $500. If it's not less than $500, this policy will be deemed to have failed. And we've got the evaluation mode on this policy set to a soft mandatory, which means that it basically provides an override or approval process. And so anyone who's got a policy or administrator access on this particular workspace can come in, review this change, work out with their discretion if that's acceptable. Oh, because I changed the, sorry, let's go back and do that one more time. I changed the instance type as well before and didn't do that demo. This is now much smaller. Discard that run. So this should look at making sure the delta is less than $500 a month. And in that scenario, it's fine. If it's over $500 a month, which it should be now that we have many more nodes, it'll come back and say, hey, this needs approval. Someone can come in and approve that process and say this is fine for whatever reason, provide a reason, click override, and the plan proceeds on as usual, and someone can then accept that and apply the change. This will take about another 2 seconds, hopefully. I am failing at my math today. We are just short on the number of nodes. My apologies. What I'll do in the interest of time, though, is we'll move on and I'll demo both of the policy failures at the same time. So let's say we've got a maximum size of 70. We'll see here, though, we've estimated all 70 of those nodes. It's just because I moved to a T3 micro. They're actually quite cheap. So it's not expensive to run that many. And so now what we're going to do is run a really large cluster with some very expensive things. And this is one of those examples where a simple change like this from an instance family, from a micro to a 2x large, can seem fairly trivial, but it actually has very big impacts. And it's running. What this policy is going to enforce is the max budget Sentinel policy here. So similar to the last one, what we're doing is we're taking the cost estimate, but instead of taking the delta, we're actually looking at the proposed monthly cost, which is the aggregate of all of the resources Terraform is aware of within this workspace that we've generated the cost estimate for, and we're going to make sure that it's less than $10,000. Now, if it's not less than $10,000, this policy will fail. And this one is set to a hard mandatory. So this is kind of a scenario where you see here, the change here is going to be $16,000. So this is a scenario where for maybe a development or a staging environment, you might just have a company rule where it's like, we want to give people freedom to experiment, but within very strict boundaries. Like there's just no scenario where we're happy with a dev or a staging environment costing us this much money. So we're going to have a very hard limit on what's allowed in terms of resources. And we'll see here in the log output exactly where it's failed. But the two things to call out here is that we failed the cost control max budget policy. which is this one I'm showing you here. We also failed the modest increases, and that's the change was significantly more than $500 for the month. And so you see here, this apply will not run. There is no override process. This was a hard mad tree failure. There's no opportunity for someone to go through this unless we decide to go and change the actual underlying policy itself. So Sentinel provides you very sort of hard guardrails to make sure that you're managing costs in a way that's optimal for your business. And so that's the end of my demo. I might throw to Jordan now. Jordan, do you want to take over and introduce everyone to clustering?
Surely, thanks for that. And clustering is not quite as fancy as a feature we just looked at, but it's just important to businesses and to our customers. So when you look at where we are today or where we were a month ago, you were really limited to running TFE on a single instance. And this brought a couple of challenges, mainly around performance and reliability. But you were stuck and limited to how large a single box could go for performance. And then with availability, one box is just never a good story. And so we went down the path of how can we solve both of these things while keeping installation simple. Let's step back though a second and see how this really affects customers. A couple of examples, and I actually have names. GM Cruise, as you probably are familiar with, do a lot of automated driving, and the pace of their provision varies daily, but they can have up to 1,600 runs a week. And some of these were taking up to an hour to run, either because of the lack of CPU or just because the queue sizes were backing up so much because of the lack of horizontal scalability. And really their only option was just to keep increasing the instance size. And at some point you really do hit a hard limit there. Now we talk about reliability. It's important to all businesses, especially the ones the size of a PricewaterhouseCoopers. And they had a hard requirement that instances had to be able to go down, whether because of failure or because of maybe needing to be repaved every 2 weeks to keep up with standards. But either way, these instances need to be able to go down without the platform going down, because the entire infrastructure is provisioned through Terraform, and even minutes would cost millions of dollars. And so the solution here was really a redundant, horizontally scalable cluster. And this gives us both the performance and reliability stories we were looking for. And it's pretty much common to any kind of SaaS deployment that you would run yourselves. And so what we ended up with were actually two types of nodes. We have a set of primary nodes, which hold all your stateful sets, such as a Postgres server or a Redis queue that controls the back end. But then also another group of secondary nodes, and this is really where the horizontal scaling piece comes into play. If you're deploying into something like AWS, these are usually deployed behind an auto scaling group, and really allows you to react to demand and to your infrastructure. And so these primary nodes have some CPU, but your secondary nodes are really where you grow to run at like concurrent APIs or concurrent runs, whether those API calls are coming from different clients or actually the browser. It allows you to scale to a number of clients at once. And of course, when you talk about a cluster, the biggest thing you're getting is availability. As long as you run a minimum of 3 primary nodes, you're guaranteed to have uptime when you lose a node. And depending on your risk tolerance, you can keep going up. As long as you have an odd number, you'll be able to have consistency between your cluster, even when losing multiple nodes. And this will eventually include also the internal Postgres database, which will be clustered and put across the cluster. That's coming later this quarter. Now, when we went from like a single instance to setting up a cluster, it's a big difference as far as the complication and what's involved. There's a lot of moving pieces just to get the cluster talking. And we knew we couldn't go down the route we were before with just a simple binary installer. And so what we ended up with was an easy and repeatable process using Terraform to actually install Terraform itself, Terraform Enterprise itself, excuse me. And so what we have are 3 public modules on the public registry that can deploy a cluster into any of the public clouds, whether it's AWS, Azure, or GCP. And you can really get a cluster set up with just a few variables in about 20 to 30 minutes, depending on how the platforms are acting that day. And we knew when we went this route, though, we would never have a solution that could work for everyone. And so that's really why we wanted to make the code publicly available. And so our customers are welcome to fork these repos and kind of bend and twist these modules to fit their business needs, whether that's for security requirements, or maybe they just want to deploy in a special way or not use specific infrastructure that's not allowed. Some companies, for instance, can't use app scaling groups in AWS. Now, we talked about the 3 major clouds and how we have public modules there. Now, there is also a story for private data centers as well. using external services. And we have a custom wrappers that we've used in our public modules that are available to you to set up installations. And we're happy to work with you to get that going. And finally, when we talk about being able to customize and what can you do with these variables, it's everything from which instance sizes or which instance base images you're using in operating systems to actually the cluster size itself. Most of the things you were used to kind of upgrading in a UI, you're actually now able to set in a simple Terraform config and just do a plan and apply. Now I wanted to show you just for a second here how easy it is and kind of what these modules look like. And so if you go to the provider registry today and just simply search Terraform Enterprise, you'll see these 3 modules available. Let's just look at AWS one for a second. This is really almost as easy as it is to install TFE as a cluster today. All you have to do is add in a VPC ID here and a couple other variables, and you plan and apply, and you'll have a cluster running TFE in AWS in about 20 minutes.
Sorry, we're not seeing your screen, Jordan.
One second, I'm sorry for that. Can we see this now?
Yes.
That's it. Yep.
Perfect, thank you. We even tested it today. You know, Zoom is the hardest software, I have to tell you. We've built all these hard things to provision the world's infrastructure, but we still can't use Zoom. So anyhow, you come in here to the private registry and search Terraform Enterprise, and you're presented with the different modules for all the public clouds. Here we're looking at the one for AWS. And you see over here in the example instructions, it's really this easy. You just set a source and a version, and then add a couple of variables. For AWS, it's actually the minimum. You have to set a VPC, and then just which OS you want to use. And you can do the plan and apply and have your cluster running. The really good thing about this being in the registry is that the documentation is all here right for you, and it's all cloud specific. So you get to see a nice example of the diagram, but more importantly, going through the inputs and outputs and seeing the customization that's allowed. So here you see you route it up with a Route 33 domain, you give it your standard license file that you always have, and the VPC ID, and that's really all that's required. We have options for doing air gaps and which kind of AWS access keys you want to use. You can have custom certs. Basically anything you can do with V4 with custom code, you now can do with variables inside our public modules. And again, you can see the outputs here. You have an application endpoint for actually where it is, the health check, the install ID, the installer date, URL. There's also some, if you want to automate the actual creation of the first user, you can get out the token to do that and things such as that. So it really allows you to completely automate the experience and set up your cluster in no time. Really, that's all there is to it. Again, if you go back to the private registry here and simply search for Terraform Enterprise, you'll see all 3 of them for the major clouds. And if you need help getting set up with VMware or any other kind of private data center like OpenStack, we're working hand in hand with customers today. So looking forward to hearing from some of you.
Great. Thank you, Jordan.
Oh, gosh. Sure thing. I was trying to find our slides again.
Is it stuck on? Oh, there we go.
There we go. And again, we have some resources here if you all want to interested to hear more. Of course, always welcome to contact sales. They're always your first point of contact. But if you're a current customer, your technical account manager can also, you can reach out to them and get information on how to set up clustering or to get a demo on cost estimation. And we also have a couple good blog posts here that announce the features we went over today, along with having video demos for both. With that, I'll kick it to Caroline.
Great. Thanks. So it looks like we had 2 questions come in from the chat and the Q&A. If other folks have questions, feel free to type them into the question box right now, but we'll go over the first one. So both of them are for cost estimation. The first one comes from Joel and asks, what's used as the source for pricing to do the estimate in cost estimation?
We use the public providers public pricing list. And so, you know, what we really wanted to do with the first launch of this feature was make sure that we were giving people sort of, you know, a really solid estimate on, I guess, what, like I said, estimate on what the resources were without being sort of super granular and specific on sort of nuance that could be very customer centric. We're looking into what to do next. And so anyone who's got, private pricing or deals, RIs, whatever it is that influences that, we're really keen to, speak to you and understand exactly what you want to do with that information and what direction we should take the next one.
Okay, great. We have another quick question. Is cost estimation only for Terraform Enterprise?
No, it's available in the governance tier in Terraform Cloud as well.
Yes. And for those folks who have not signed up for Terraform Cloud before, you can sign up by accessing terraform.io, and there should be a sign up button. Great. And then we have another question around cost estimation. Is there a feedback loop from the environment back to Terraform? For example, 3 microservers are configured, but my service is only using 1 server. Is there a way for Terraform to figure out that infrastructure was overconfigured and needs to be scaled down?
So with that scenario, what we'd usually recommend is leveraging whatever the cloud provider's native controls are for that. So in the example I gave, it was AWS, so an auto scaling group, or if it's Azure, it's a scale set. But basically using the metrics to drive the scale of what's running at any point in time based on some metric like memory usage or CPU, and setting your environment to scale in if it's over provisioned. What that tooling, so there are controls that are better placed within the vendors themselves to manage that and do that very dynamically and responsively. Where that falls short, that's good for instance counts. Most of the providers aren't very good at helping you work out which family. So in the example I gave, we showed a quick example between switching between a micro and a 2x large. If you're still running 3 of 2x larges, you still might be over provisioned because you've got a family that's too high. And so we're working with, there's a partner we're doing a shared demonstration with at reInvent called Densify that's worth looking at, which will help take some of those metrics, and you can feed that into Terraform and into your cost estimation to help you basically dynamically choose the right family of instances to be running on your cloud as well. So we'll have a look at sort of some third-party integrations for that aspect of it.
Awesome. We have one more question that came in.
Roadmap.
Yes, roadmap. What are future features planned for Terraform Enterprise? I see it mostly as cost estimation and clustering right now. Glenn and Jordan, feel free to chime in.
I'll throw to you first, Jordan. Oh, you're on mute, mate. Oh, me, okay. So for my part of the world, we're looking at improving workflows for service accounts, trying to understand exactly what people are doing with third-party or internal API integrations and how we can better support those. We are launching support for Sentinel to be able to talk to external services. So you can issue a HTTP request and have data from another service come in and make business decisions or policy decisions around that. We are looking at ways to have more granular permission controls around state and access to state. Also on the roadmap for my team in particular around governance is having that first policy experience, like the time to value with Sentinel, reducing that, making it just easier to get started. And we're researching exactly how we do code reuse. As people have more and more Sentinel policies, they end up building this library that they want to share across multiple policies. Do we have modules or imports or some kind of sort of coding construct to allow that to happen much more easily? They're sort of the near-term priorities for us.
Very cool. And yeah, on the platform side, we're really focused in on just simplifying this installation, reducing the amount of moving parts. We're looking at bringing in the Postgres internally, possibly internalizing the front load balancer. So that's just one less piece you have to provision. On some of the other teams, we're also looking at infrastructure pipelines and how you could possibly link workspaces in between each other. So you could have one workspace, and once it's planner applied, it can emit a variables to another workspace and trigger planning applies there, whether automatically or needs kind of someone to go check it out. We're also doing some little things around the UI. These are just little small helpful things like adding descriptions to variables. So we all know naming is one of the hardest things. So just giving you a few more characters there to explain what variables are for. But yeah, just a lot of little polish you'll see coming out as well.
Great. I think that covers all of the questions that we received during the webinar. So at this time, I'd just like to close out the webinar and say thank you, Glenn and Jordan, and thanks to the audience for joining today. I hope everyone enjoyed today's webinar and has a better understanding of cost estimation and clustering features available in Terraform Enterprise and Terraform Cloud. And if you don't have Terraform Enterprise currently, as Jordan mentioned, you can reach out to any of our sales folks from HashiCorp.com and fill out a form to contact sales. And then finally, as mentioned at the beginning of the webinar, this was recorded and we will be making this recording available within a couple business days. And it will be sent out to everyone who registered. Thanks, everyone. Have a great day.